For weeks, the desert Southwest has been trapped under a dome of high pressure so intense it broke records that have stood for decades. Death Valley pushed past 126 degrees. Palm Springs touched 120. Phoenix and Las Vegas spent night after night without the relief of cooler air because even after sunset, the heat simply refused to leave. And now, finally, it's breaking. You'd think that's the end of the story. Relief arrives, temperatures drop, everyone exhales. Except the scientists watching this pattern aren't relieved at all, because what typically follows a heat dome like this one isn't calm weather, it's a whiplash. And in the Southwest, that whiplash has a name: monsoon season. This is the story of why the end of extreme. Heat doesn't mean the danger is over. It means the danger is about to change shape entirely. To understand what's coming, you have to understand what the Southwest just went through. This wasn't a single, isolated heat event. It was the third major heat dome to grip the country this year, part of a pattern that's repeated itself since February. Roughly 80 million Americans found themselves under heat advisories at the peak of it, with almost no overnight relief for days at a stretch. At least 44 deaths have been linked to this summer's heat dome so far. The reservoirs tell their own version of the story. Lake Mead and Lake Powell, two of the largest water reservoirs in the country, have dropped to historic lows, and the extended heat has only accelerated evaporation across a river basin that tens of millions of people depend on for water. Meanwhile, more than 3.3 million acres have already burned across the United States this year, well above the seasonal average, with the majority of that fire out west. In Colorado alone, the Aspen Acres fire has burned more than 100,000 acres, making it one of the largest wildfires in the state's history. So when meteorologists say the heat is breaking, they don't mean the danger is gone. They mean the atmosphere is about to flip into something else entirely. It's worth sitting with how unusual this year has actually been. Heat domes typically show up once, maybe twice, in a bad summer. This year, the pattern repeated itself across February, March, and now again into late July and early August, building over the west, pushing east, weakening, and then reforming somewhere else. Meteorologists have been tracking it less like a single event and more like a recurring feature of the season itself, one that keeps returning to the same stretch of the country with only brief pauses in between. That repetition is part of why this particular ending matters so much. A region that's been baked for months doesn't just cool off cleanly. The ground has spent weeks radiating heat back into the lower atmosphere. The vegetation has spent months losing whatever moisture it had left, and the soil across huge stretches of the Southwest is sitting in moderate to severe drought. None of that resets the moment temperatures drop by 10 degrees. It just changes what kind of trouble is coming next. Here's what's actually happening, mechanically, right now. As the heat dome that baked the Southwest for weeks finally weakens and shifts, a different weather pattern is moving in to take its place, the North American monsoon. It's an annual pattern, but this year it's arriving directly on the heels of one of the most extreme heat stretches on record, into a landscape that's been baked dry for weeks. A massive high-pressure system begins pulling deep tropical moisture northward, up from the Gulf of California and the eastern Pacific. That moisture collides with the desert, heat still radiating off the ground, and the result is explosive. Towering thunderstorms that can go from clear skies to severe weather in under an hour. On paper, this sounds like exactly what the Southwest needs. Rain, after weeks of triple-digit heat and worsening drought. But meteorologists are already warning that this rain won't arrive the way anyone would. Hope. It's expected to be wildly uneven. Torrential downpours flooding some communities, while others nearby get almost nothing but dry lightning. And dry lightning, in this context, might be the most dangerous part of the entire pattern. There's also a more immediate, less dramatic risk hiding in that uneven rainfall. The swing itself catches people off guard. Communities that have spent weeks adapting to extreme heat, staying indoors during the hottest hours, watching for heat advisories, checking on elderly neighbors, often aren't mentally braced for the switch to flash flood warnings and severe thunderstorm alerts just days later. The instinct, after a brutal heat stretch, is to welcome any storm as relief. That instinct is exactly what meteorologists are trying to get ahead of this year. Dry lightning is exactly what it sounds like. A lightning strike with little or no rain reaching the ground beneath it. The storm itself may be miles away, or its rain may simply evaporate before it hits the desert floor. That lightning still has to go somewhere. And after a summer this dry, it's landing on vegetation that's had months to become dangerously flammable. Combine that with the wind. Powerful downdrafts from these storms can trigger walls of dust known as haboobs, and generate straight-line winds strong enough to snap power lines and fan any spark into a wildfire within minutes. Forecasters have already flagged wind gusts in the strongest of these storms reaching 60 miles per hour. So the very storms meant to end the drought are also, simultaneously, capable of igniting new fires across a landscape, still recovering from the last ones. This is the part scientists want people to understand. The transition itself is often more dangerous than either extreme on its own. It also creates a strange kind of double jeopardy for fire crews already stretched thin. Personnel who've spent weeks fighting fires sparked by heat and drought now have to shift their attention to fires sparked by lightning, often in different, harder-to-reach terrain, while simultaneously watching for flash flood risk in the same general region. Firefighting resources don't multiply just because the threats do. In a season where over 3 million acres have already burned nationwide, that strain is landing on a system that was already operating near its limits before the monsoon moisture ever arrived. There's a second, quieter danger buried in this transition, and it has to do with what fire does to soil. When wildfire burns through a hillside, it doesn't just destroy the vegetation on top. The heat, sometimes exceeding 1,000 degrees Fahrenheit, bakes the soil itself, creating a water-repellent layer just beneath the surface. Scientists call this hydrophobic soil. Normally, rain falling on a hillside gets absorbed. Vegetation slows it down, and soil soaks much of it up before it ever reaches a stream. But on a burn scar, that entire system is gone. The scorched soil can't absorb water at all, so rain that would normally sink into the ground instead sheets straight across the surface, gathering speed, picking up ash, rock, and debris as it goes. That's how a modest rainstorm on a burn scar turns into a debris flow. A fast-moving slurry of mud, boulders, and burned vegetation that geologists compare to the force of a moving freight train. These flows don't need a major storm to become deadly. Even a short period of moderate rainfall on the wrong terrain can be enough to trigger one. With over 3.3 million acres burned across the country this year alone, there are now vastly more burn scars sitting exposed and vulnerable than usual, right as the monsoon moisture moves in over them. Every one of those scars is a potential debris flow zone the moment heavy rain arrives. This is precisely why federal agencies operate dedicated flash flood and debris flow warning systems specifically. For recently doesn't end when the fire goes out. In many ways, it's only just beginning. Geologists who study this process point out that the danger window can stretch on for years after a major fire, not just the following rainy season. Root systems that once held hillsides together take seasons, sometimes years, to regrow enough to stabilize the soil again. Until that happens, every storm that rolls over a burn scar is essentially rolling the dice on whether this is the rainfall event that finally triggers a slide. Communities, downstream of large recent burns, and there are now more of those than usual, are effectively living underneath a hazard that resets every time it rains, for years after the fire itself is long forgotten by the news cycle. All of this, the heat, the sudden storms, the fires, the floods, fits into something climate scientists have started calling hydroclimate. Dangerously dry conditions and dangerously wet ones, happening in the same place, sometimes within the same season. Daniel Swain, a climate scientist who has studied this pattern extensively, has pointed out that these wide swings between drought and flood are becoming a defining feature of the region's weather, rather than a rare exception. Research published in the past 2 years backs this up. The swings aren't just happening more often, they're intensifying, and the transition between the two extremes is becoming faster and sharper than historical weather patterns would predict. That matters because human systems, water infrastructure, wildfire response, emergency planning are generally built to handle one extreme at a time. A drought response plan, a flood response plan, a wildfire response plan. What they're not built for is all three arriving back to back, sometimes overlapping, in the span of a single season. That's exactly what the Southwest is facing right now, and the timeline keeps compressing. Where these swings between extremes once played out over years, a multi-year drought followed eventually by a wet cycle, researchers are now documenting transitions that happen within a single season, sometimes within a matter of weeks. That compression is precisely what makes this pattern so hard to plan around. A reservoir manager, a wildfire agency, or a city's stormwater system can adjust to a slow-moving multi-year trend. Adjusting to a hazard that flips character every few weeks is a fundamentally different, much harder problem, and it's one that a growing number hasn't built its infrastructure to absorb yet. There's a policy dimension to this story too, and it's worth understanding because it shapes how prepared communities actually are when the whiplash hits. Under current federal law, extreme heat isn't classified the same way a hurricane or flood is. It doesn't automatically trigger the same kind of disaster declaration that would unlock FEMA support. A bipartisan group of lawmakers has introduced legislation that would change that, adding extreme heat to the list of federally recognized disasters. But as of now, it hasn't been passed into law. That gap matters more than it might seem. It means that even after summer with dozens of heat-related deaths and record-breaking temperatures across major cities, the federal response framework often doesn't treat the heat itself as the kind of emergency that triggers rapid, coordinated aid. right before that same region pivots into flash floods and wildfires, hazards that do trigger that response. In other words, the most dangerous phase of the year, the transition, is also the phase the system is least built to handle smoothly. Water managers face a version of the same problem. The reservoirs that supply water to tens of millions of people across the Southwest have been drawn down for months by heat-driven evaporation and ongoing drought. A burst of monsoon rain, however dramatic it looks on the ground, generally isn't enough to meaningfully refill a reservoir system that large. So even as flash floods make headlines, the underlying water shortage that made this summer's heat so dangerous in the first place often continues, largely unchanged, just temporarily masked by a few weeks of dramatic storms. So what does this mean if you're anywhere near the Southwest over the coming weeks? The heat breaking is genuinely good news for anyone who's spent the summer sheltering from triple-digit days. But it's not a green light to relax entirely. It's a signal to shift your attention to a completely different set of hazards. Flash flooding can develop with almost no warning, especially in canyons, dry stream beds, and any terrain near a recent burn scar. Water that looks shallow and slow can rise and accelerate within minutes. Dry lightning means a storm doesn't need to drop visible rain to be dangerous. It can still spark a fire, especially in vegetation that's been drying out for months. And the transition period itself, the days and weeks where heat, storms, fire risk, and flood risk are all elevated simultaneously, is exactly the stretch scientists are asking people to take most seriously, precisely because it doesn't feel as viscerally dangerous as either extreme on its own. Here's the uncomfortable truth underneath this entire story. The Southwest isn't simply moving from a bad season into a calm one. It's moving from one kind of extreme into another on a timeline that's getting faster and less forgiving with each passing year. The heat dome that just broke records across Death Valley, Phoenix, and Las Vegas didn't happen in isolation. It followed the same basic pattern climate scientists have been documenting for years now. Extended, PT, sometimes violent transitions into the opposite extreme. What comes next in the Southwest isn't rest. It's rain falling on ground that can't absorb it. Lightning striking vegetation that's had all summer to dry out. And emergency systems built for one disaster at a time, now being asked to handle several back-to-back in the same few weeks. The heat wave is ending. That part is true, and for millions of people it's a real relief. But the scientists watching this pattern aren't focused on the heat anymore. They're focused on what happens in the days right after it. Because increasingly, that's turning out to be the part of the story nobody planned for.